This is new error-correcting code. You say basically it cracks the code on science challenges of actually making quantum a reality.
Absolutely. I mean, the whole thing here is that we cracked the code in actually building something that's realistic and planning for this with a full architecture, which gives us the roadmap to go year after year of new technologies to hit that milestone in 2029 with IBM Sterling.
Can you take us from here in 2025 to 2029? What needs to be achieved? Because there is so much hype. We kind of want to disentangle what actually becomes reality.
Yeah, no, absolutely. That's a great question. There's a lot of work that's been going on in small demonstrations of error correction and the concepts that make us believe that error correction can work. But what we've defined is a technology roadmap that takes us from an error-corrected memory and the technologies that go into that, then into operations across multiple memories, and then into a larger scale system that brings in the operations that are needed for universal control to do any kind of algorithm. That gets us to Starling. So year after year of new technologies in our roadmap.
Okay, people are excited. IBM shares are at a record high, and I'm sure there's no surprise that has come in at the same time as some of your announcements. Can you talk to us about the different ways that different companies are deploying this? Because we've had, a year or so ago, what was it, the Heron chip from you guys really set the bar, but we've also had the Willow chip coming from the likes of Google. You've had Ocelot out of Amazon, and there are different ways of doing quantum.
That's right.
How is what you're doing different from some of the other competitors?
Yeah, so I think we've really taken an approach of getting this out there and really building the whole ecosystem around us. We've actually been putting these out on the cloud since 2016. First, just a 5-qubit machine back then, right? And we've been successfully scaling since then. And we have multiple 100-qubit machines, the Heron processors, that are available to our cloud users today. So there's an ecosystem of many users and companies that are leveraging our machines to actually find and discover new algorithms and applications.
When you say many users, what are we talking about?
We have over 500,000 users. We have a business ecosystem, our IBM Quantum Network, of nearly 300 institutions, companies, startups, national laboratories, academia.
And the reason everyone gets so excited when we hear of the latest, greatest chip, when we hear of a roadmap to 2029 is because of the things it could do.
Absolutely.
But what are they doing it with these 500,000 people that are already out there?
Yeah, so there's a lot of work that's getting ready for the larger systems, but also we're in this phase where we're going to hit quantum advantage in the next few years.
And what's quantum advantage?
It's when we can do something that's cheaper, faster, or more accurately using a quantum computer plus classical computer than just a classical computer alone.
It's a bit like AGI, but for quantum versus normal computers.
Yeah, and you're already starting to see the intrusion of using it with high-performance supercomputers to look at things like molecular structure, which is a very hard problem that you tend to only use high-performance computers for.